Hi guys, so today we're going to dive a little deeper into implicit differentiation. So in the first tutorial, I went over just the method and how it's used. So today we're actually going to use implicit differentiation to find the derivative. So notice that the instructions are find the derivative of y with respect to x given these two functions, which are both in terms of x and y. So we're going to start off just doing what we did last time. The nice thing about number one is they're different terms separated by plus and minus signs, so we can derive each one separately. Just make a note that if you derive y, we put dy over dx right next to it. So let's start out y to the third power. If I derive that, sorry, I don't know why my pen is acting up. If I derive that, this would give me 3y squared, and remember dy over dx since I derived the y, not actually x, and then plus y squared would be 2y, again, noting dy over dx, minus 5y, which is just minus 5, dy over dx. And we have a function there now in terms of, or we have a term that's in terms of x. So minus x squared, if I use the power rule, no other reason I'm going to put this in a different color than the fact that, it's in terms of x. So minus, or it was supposed to be a different color, minus 2x. And then from here, there's an equal sign. Keep it rolling. Equals. What's the derivative of any constant? It would be 0. I know you answered that, um, even though I can't hear you. So what do we do from here? Well, there's a couple of different options. First of all, these three terms have something in common. They have dy over dx in common. And if I factor that out of each one of these first three terms, that would give me 3y squared plus 2y minus 5. And then I'm going to bring down the rest of this. Now remember, what you're looking for is the derivative of y with respect to x. I have that here. I just need to isolate it, meaning get it by itself. So we're using PEMDAS. We're going to move everything that's not dy over dx to the other side of the equal sign. We're going to isolate that, just like you did when you were just getting x by itself in algebra. So always get rid of the adding and subtracting first, and remember dy over dx is not being added or subtracted to anything in this green parentheses, it's being multiplied. So we're going to get rid of this minus 2x first by adding 2x to both sides of the equal sign. And I'm going to bring everything down. So I have dy over dx 3y squared plus 2y minus 5. And then it equals to, I have 0 plus 2x, which is just 2x. So to get dy over dx by itself, it's being multiplied to this entire parenthesis, so I'm going to divide by this entire parenthesis. Whatever I do to one side, I do to the other. And since I'm out of room, I'm going to go like that. Okay, so this divides out, and you're left with dy over dx equals, so remember that's what we're looking for, the derivative of y with respect to x. We got it by itself. It equals 2x over the squiggle, which is just my way of rewriting this same denominator, 3y squared plus 2y minus 5. So that's pretty much how we're going to use implicit differentiation. We're going to apply a little algebra to it after we find the derivative of each term. So if you look at number 2, I'm kind of using the same style of the problem. So I have x squared. That would just give me 2x. And then minus y to the third power. Well, using the power rule, that would give me negative 3y squared, but it's not in terms of x, so I'm going to note that. And now the goal is to get dy over dx by itself. Again, it's being multiplied to this entire negative 3y squared term. It's being added to 2x. So algebraically, we get rid of the adding and subtracting first. We subtract 2x to both sides of the equal sign. This would leave me with negative 3y squared dy over dx. Again, dy over dx is being multiplied. Notice nothing between these two terms, so they're being multiplied, even though it's a negative 3. And then equals 0 minus 2x is negative 2x. The goal again is to get the derivative of y with respect to x is dy over dx by itself. So again, it's being multiplied to negative 3y squared. I'm going to divide both sides by negative 3y squared. And this would give me dy over dx, the derivative of y with respect to x equals 2 negative divides out to be a positive, so I'm going to get rid of those negatives and be left with 2x over 3y squared. All right, guys, I hope this helps.